Good morning to all. I'm Dr. Priyadarshini, Professor of AC Department, Rohini College of Engineering and Technology. In today's class, we shall discuss about the frequency division multiplexing. So it's a multiplexing scheme. So frequency division multiplexing, it's an analog multiplexing scheme. So in case of multiplexing, more number of signals can be combined and that can be transmitted through a single channel. So in frequency division multiplexing, from the name itself, we can say that the available frequency is divided into number of sub carriers, and all the signals from the number of users that can be transmitted at the same time. So here each users are allocated by the sub carriers or sub channels. So the total available channel is divided into number of sub channels, and each users are allocated with the particular sub channels. Because of these schemes, a large number of users can transmit the time slot at the same time, but different frequencies. So FDM is an analog multiplexing technique that combines different signals by modulating each analog signal with different carrier frequency. So here the total bandwidth is divided into a set of frequency bands, so which bands do not get overlapped. So the frequency bands are separated from one another by strips of unused frequencies, which are called guard bands. So the purpose of the guard bands is to avoid overlapping of the adjacent signals. Next, the modulated signals are combined together using a multiplexer in the sending end. The combined signal is transmitted over the communication channel, which allows multiple independent data streams to be transmitted simultaneously. So this is the transmitting end of the FDM modulator. So here different users are there. So the signal from different users get received by the receiving end. And we are using different modulators. That is, first user has a particular carrier frequency, second user has different carrier frequency, and third user has different carrier frequency. So whatever the number of number of users are used, each users are allocated by different carrier frequencies, so that the signals from each users are multiplied by the corresponding carrier frequencies, and next the signals are get combined. So at the output of the modulator, it produces the frequency modulated signals, and all the frequency modulated signals are get combined, and that may be get added up, and that is transmitted through the channel. So next, demultiplexing of FDM signals. Once the signals are get multiplexed, it produces the multiplexed FDM signals, that is frequency division multiplex signals are generated, and that is transmitted through the channel. In the transmission path, there may be chances for addition of noise as well as interference. So the receiving end, our objective is to recover the original signal without any loss as well as without any noise. So the process of recovering our original signal is known as demultiplexing. So by definition, we can say that demultiplexing is the process of recovering the individual baseband signals from the multiplexed signal. So at the receiving end, the individual signals are extracted from the combined signal by process of demultiplexing. So this is the receiving end. The receiving end, whatever we have done, the transmitting end, whose inverse operation is done here. So the received input, which receives the combined FDM signals, and also along with the FDM signal, the noise components are get added. So first of all, the received signal is passed through the bandpass filter. So here there are n number of users are there. So we are using the n number of bandpass filters. So each bandpass filter will allow the particular band of frequencies, and all the other frequency bands signals at other frequency bands are get eliminated. So because of that, the added noise, the transmission path is get eliminated, and the needed signal is passed through the bandpass filter. So here the bandpass filter is also constructed in such a way that whatever the carrier frequency, so the carrier frequency transmitting end, we uses three frequencies, that is F1, F2, F3. So the same frequency bands is designed in the receiving end also. So the first bandpass filter that will allow the signal of frequency F1 alone, and the second bandpass filter will allow the frequency of the band of F2, and the third that will allow the signals of frequency of F3. So finally, these signals are get demodulated and the signals are separated. So, so what's the destination end? That is, the separated signals are routed to the corresponding destination users. So this is the basic block diagram of the FDM system. So it has the transmitting end. It consists of low pass filter, modulator, and a band pass filter. So the user's signal from the message input is passed the low pass filter, and the nonlinearities are removed, and then it is modulated by using the product modulator. And next, the signal is passed the band pass filter, and the signals are get combined. So at the transmission end, in the reverse operation, it has number of band pass filter. It allows a particular band of frequencies, and the signal is given to the demodulator. So the demodulator output is passed to the low pass filter. Likewise, the low pass filter allow the signal that are same as that of the original message signal. So the if we are transmitting symbol one from transmit data from first user, then should to destination into first user. The one to the user from one data is received properly. Thank you.